Hello everyone. So in this video, I'm going to now solve question number 13 that is here. So again, based on this question, I got a few students have doubt how to solve this. So that's why I'll just quickly show how to solve it. Question number 13 that we are doing now. So as usual, we begin by creating a circuit diagram. So let's do that. We got a transformer. So 5 kVA 500 by 110 volt transformer. So let's begin by doing that. So its capacity is 5 kVA and the voltage is, sorry, not this. I need to move this here. - 500 by 110. That's the capacity. And the equivalent resistance referred to primary side has been given. And the load is connected on the secondary side. So equivalent resistance referred to primary side is HV side, that is 1.24 and 4.05. So this is the total impedance that we are getting here. This is R naught 1 plus J X naught 1. So here the core loss component are ignored. So that is fine. Okay. So now let's continue. A lagging load is being supplied, resulting in following meter readings. Meters are placed on the HV side. So don't confuse this with the short circuit test or open circuit test. It is just that data is given saying that meters are there. So just given that I1 is 9.2, V1 is 500, and P1 is 3. So 9.2, 500, and 3. Okay, so let us do these values. So here the current is 9.2 amperes and the voltage is 500 volts and the input power P in is 3 kilowatts. Okay, 9.2, 503. For this condition, calculate the voltmeter, what a voltmeter would read if connected across the load terminals. Neglect the no load current of the transformer. So this point is also given, no load current we can neglect. So now if I connect a voltmeter across the load terminals, so what would this voltmeter be reading? So because there is all the resistance is already transferred, there won't be any drop here. So whatever is this V2 dash is nothing but your final answer. So what is V2 dash? That is nothing but V1 dash. And using this transformer, so V1 dash multiplied by 110 by 50 will give me the V2 dash. But how do you get V1? So that is nothing but V minus drop. Okay, so V1 dash is nothing but V1 or V input minus the drop, the voltage drop. Okay, so here you can do two ways. You can do exact calculation using complex notation, or you can do approximate calculation using the vector diagram. Okay, so let me explain what I mean. See, assume that this is the voltage. Okay, so this is the input voltage. So now, what is the current? The current will be lagging, right? Because the it is given current is lagging. So then the drop. So actually, because it is drop, I have to subtract. So I have to take in the negative direction, and then one more drop will be like this. So here uh, it will be like this. So this is the VR drop and this is the VX drop. So this is nothing but this will be phi. So VR cos phi, and this will be Vx sin phi, and finally we'll get the V1 dash here. Okay. So in my previous video, I have done the same thing, so you can just refer to that. So let me show the calculation first now. So first thing is, first I need to find the power factor. Okay. So what is the power factor? So V1 I1 cos phi 1 is nothing but P1. Okay, so this I'll consider P1. So then power factor is nothing but, so 3000 divided by, because it is 3 kilowatt, I converted it to watts. The voltage is 500 and the current is 9.1. So this will give me the whatever the power factor. Okay, so let's calculate. So 3000 divided by 5000. Okay, here itself we can do. So 6 by 9.1. Okay, so let's do that. So 6 divided by 9.1. So that give me 0.6593. 0.6593. Once I have the cos, how do I find the sine? So sine phi is nothing but cos inverse of this and apply sine to that. Okay, so I'll just show that. So to this, I'll go for inverse of cos answer. So this is my cos inverse, so 48.75 degrees. Now I'll apply sine to this, sine of answer. So 0.7518, 0.7518 is the sine value. So now I will find the drop. Okay, so what is the drop? So current multiplied by R naught 1 cos phi 1 plus X naught 1 sin phi 1, because it is given that the power factor is lagging. Otherwise, this will become minus if it is leading. Okay, what is the current? 9.1. Oh, sorry, 9.2. Let's go to yellow. So 9.2 multiplied by R naught 1, 1.24 multiplied by cos 6593, then X naught 1 4.05 multiplied by sine 7518. So again, this is a calculation I need to do. I'll just use my hand calculator. So 1.24.6593. So 0.8175 plus, so this is 3.0448. So to this I will add a 0.8175. To that I'll multiply 9.2. So totally I'm getting 35.533 volts of the voltage drop. Okay. So now what is happening? So I apply 500 volts here, then the voltage drop here is 35.533. Now you may ask, how can I simply subtract, because it is not an AC circuit. Okay, so if this is 500 and I, how can I simply subtract? I should do complex calculation, but this formula is assuming approximate voltage drop, so it is fine. So 500 minus 35.533, so that is V1 dash equal to, so if I subtract 500 from this, I'll be getting 464 point. 467. So that is here. Now I step down to the secondary side. So the ratio, remember, it is 500 by 110. So then from that V2 dash I can calculate. Okay, so V2 dash is nothing but 464 multiplied by 110 and divided by 500. So that will give me 102.18 volts. So if a voltmeter was placed on the secondary side, this is the voltage that it would be reading. Okay. So here it will be 102.18 volts. Let us check what are the choices. So 102.25 is the closest choice. So I'd go with answer as B. So again, I repeat, this is not the only method to solve it. The more other method I will just quickly show you. Uh, how do you solve this? Is you got the angle, right? So now you take the phasors. Okay, so I'll just delete this. So the accurate method is something like this. The most accurate method kind of thing. So okay, so here you need to use complex calculation. So V1 is 500 angle 0 degrees, and then I1 is 9.2 and the angle. So I remember 0.693. If I use cos inverse of that, some 48 degrees something it came. So now I got the I1 phasor. Then Z not 1 is nothing but again this number. Okay, so already we have that is also complex 1.24 plus j 4.05. So then this is a vector, this is a vector, this is a vector, or all three vectors or phasors, whatever. So V1 dash will be the phasor subtraction of V1 minus I1 bar and Z01 bar. So if you do this, you will get exact value of V1 as a phasor. Then you take the absolute value, then you will get the magnitude of that. So those who are interested can simply try this method. But see here, because we use this formula, so this formula simply you need not use the complex calculation. So you with your simple calculator you can solve it, and exactly answer will not be exactly same, but it will be quite close. So those who are interested can try this method and then check what you get V1 dash, and then the absolute value of that, and then again multiply with k to get the V2. Okay, so thank you. See you in the next video.